Hello everyone. Last time we had find complementary function for higher order differential equation, and there are four cases which we have learned for complementary function. First one is a real and non-repeating, second one is a real and repeating, third one is a complex conjugate, non-repeating complex conjugate, and fourth one is a repeating complex conjugate. So today we are starting with a methods to find pi. Now for equation f dy is equal to rx, that means now the function rx is not equal to 0. In that case you have to make y subject, that will y is equal to 1 upon f d of rx, and this is called yp. After eliminating d, whatever the solution you have, that is called the general solution. Sorry, it is called particular integral, and after eliminating d, the finally you get pi, and using pi we are going to write down the general solution, which is given by cf plus pi. Now there are shortcut methods to find pi. First one, if rx is equal to e raised to ax, that means the function is e raised to ax, then in that case 1 upon fd of rx, that means 1 upon fd of e raised to ax is equal to 1 upon f of a e raised to ax if f of a is not equal to 0, and x upon f dash of a e raised to ax if f of a is equal to 0. That means you have to replace d with a, provided that this f of a has a value non-zero, and x upon f dash of a if f of a is a value 0. That means if denominator is 0, then you have to differentiate this term with respect to d, and in numerator you have to put x, then put d is equal to a. If still it is 0, then again you have to repeat the same process until the value of denominator is going to be a non-zero. Now going with the example, solve the differential equation y double dash minus 4y dash plus 4y is equal to 5 e raised to x plus 2. Now writing in the form of d, that will give d square minus 4d plus 4 of y is equal to 5 e raised to x plus 2. That will give you the auxiliary equation d square minus 4d plus 4 is equal to 0, and that will give d minus 2 the whole square is equal to 0. So that will give d is equal to 2, and that means you have a repeating real values, and therefore the complementary function cf is equal to c1 plus c2x into e raised to x. So this is the case of repeating. So you have c1 plus c2x into e raised to 2x. Now for yp you have to make a y subject, and if you are going to make a y subject, then in that case you have 1 upon d square minus 4d plus 4 into 5 e raised to x plus 2. Correct? Now separating two terms. So separating two terms, that will give you 1 upon first we are going to define the case of 2. Now 2 has no power of e, so we are going to write down in a form of e raised to 0x. Okay, so now 1 upon d square minus 4d plus 4 into 5 e raised to x plus 2 e raised to 0x. Separating the terms and common out the constants, that will give you 5 into 1 upon d square minus 4d plus 4 of e raised to x plus 2 into 1 upon d square minus 4d plus 4 e raised to 0x. Now applying the case, you have to replace d by a. So here you have a is equal to 1 and here you have a is equal to 0. So here d will be replaced by 1. So 1 square is 1, minus 4 into 1 is minus 4, plus 4 as it is. Here d is replaced with 0, so 0 minus 0 plus 4. So simplifying this one, that will give 5 e raised to x upon 1. And here you have 2 upon 4, e raised to 0 will be 1. So you have 5 e raised to x plus 1 by 2. And that will give the general solution y is equal to cf plus pi. That is y is equal to c1 plus c2x e raised to 2x plus 5 e raised to x plus 1 by 2. Okay. So please remember it. You always have to write down the general solution at last. Same manner, solve y double dash minus 4y dash plus 13y is equal to 3 e raised to minus x plus e raised to 2x. Now again you have d square minus 4d plus 13 of y is equal to 3 e raised to minus x plus e raised to 2x. So auxiliary equation is d square minus 4d plus 13 is equal to 0. So using delta, that will give d is equal to minus b plus or minus under root b square minus 4ac. That is minus minus plus 4 under root minus 4 square is 16 minus 13 into 4 is 52 upon 2. And that will give 4 plus or minus under root minus 36. Under root of minus 36 is 6i. And that will give you d is equal to 2 plus or minus 3i. So a is equal to 2, b is equal to 3, then that will give you cf is equal to e raised to 2x into c1 cos 3x plus c3 sin 3x. So pi is 1 upon d square minus 4d plus 13 of 3 e raised to minus x plus e raised to 2x. Again separating the terms, that will give you 3 into e raised to 3 into 1 upon d square minus 4d plus 13 into e raised to minus x plus 1 upon d square minus 14 plus 13 e raised to 2x. Here you have to replace d by minus 1. So minus 1 square is 1, minus 4 into minus 1, that is 4, and 13 remains as it is. Here you have to replace d by a is 2, so d is 2 square is 4, minus 4 into 2 is minus 8, and 13 remains as it is. Simplifying this one, that will give 3 upon 18 e raised to minus x plus 1 upon 19 e raised to 3x. And therefore the general solution is y is equal to cf plus pi. That is e raised to 2x cos 3x, c1 cos 3x plus c2 sin 3x plus 3 by 18 e raised to minus x plus 1 by 9 e raised to 3x. Now solve y double dash minus y is equal to 16 cos hyperbolic x. So first we are going to write down cos hyperbolic in the form of e raised to, that will give you e raised to x plus e raised to minus x by 2, and that will give you 8 e raised to x plus e raised to minus x. And your equation is of the form d square minus 1y is equal to 8 into e raised to x plus e raised to minus x. Now auxiliary equation is d square minus 1, so you have two factors d minus 1, d plus 1, that will give d is equal to 1 and minus 1. So real and distinct, so cf will be c1 e raised to x plus c2 e raised to minus 1x. Now yp is equal to 1 upon d square minus 1, 8 of e raised to x plus e raised to minus x. So 8 common out and separating the terms, that will give 1 upon d square minus 1 e raised to x plus 8 into 1 upon d square minus 1 e raised to minus x. Now if you are going to replace d by a, then a is 1. So 1 square is 1, so 1 minus 1 will be 0. Now this denominator is 0, so it is the case of failure. In that case, you have to put x upon derivative. So x upon derivative of d square minus 1, that will be a 2d. Same manner here, if you are going to put minus 1, then also minus 1 whole square is 1, So again denominator is 0, and that again you have to apply x upon derivative of d square minus 1, that is 2d. Simplifying, that will give you, and again now if you are going to replace d by 1 here, so d by a is 1, so here you have x by 2, and here d by minus 1, then you will have x by minus 2. So simplifying this one, that will give you 4x e raised to x minus 4x e raised to minus x, and that will give you 4x e raised to x minus 4x e raised to minus x, 4x common out, and that will give you 4x into e raised to x minus e raised to minus x. So the general solution y is equal to cf plus pi, which is c1 e raised to x plus c2 e raised to minus x plus 4x into e raised to 4x into e raised to x minus e raised to minus x. Now case 2, if you have function rx is equal to sine or cos, then in that case d square is replaced with a minus a square. So that means 1 upon f of d square of sine or cos, that will be 1 upon f of minus a square of sine of ax, sine or cos. In the case of failure, that means if the denominator is 0, then you have x upon f dash of minus a square. So in e raised to you are replacing d by a, but here you are replacing d by minus of a square. So solving the equation y double dash minus 3y dash plus 2y is equal to 3 sine 2x. See, the equation is d square minus 3d plus 2 of y is equal to 3 sine 2x. So auxiliary equation is d square minus 3d plus 2. So you have factors d minus 2d plus minus 1, and that will give d is equal to 1 and 2. That will give cf is equal to c1 e raised to x plus c2 e raised to 2x. Now for pi, 1 upon d square minus 3d plus 2 of 3 sine 2x. So 3 will be common out. Now here you have sine, that means you have to apply case 2. So for case 2, d square will be replaced with minus a square. A is 2, so d square will be replaced with minus 4. But d is not going to be replaced. You have to put d as it is. So d square is equal to minus 4. Simplifying this term, that will give minus 3d minus 2. Minus common out, and you will have 1 upon 3d plus 2 of sine 2x. Multiplying by conjugate, that will give 3d minus 2 upon 9d square minus 4 of sine 2x. So, and that will give you, again applying d square is equal to minus 4. So that will give you minus 3 upon minus 14 into 3d of sine 2x, multiplying sine 2x inside, that will give you 3d of sine 2x minus 2 of sine 3x. Sorry, 2x. So d is nothing but d by dx. That means derivative of sine 2x is 2 cos 2x. That will give you 3 upon 14 into 6 cos 2x minus 2 sine 2x. Multiplying and simplifying, that will give you this answer. And the general solution is given by cf plus pi. That means c1 e raised to x plus c2 e raised to 2x plus 9 by x 20 cos 2x minus 3 by 20 sine 2x. Now solve the equation y double dash plus y is equal to 4 sine 2x cos 3x, and that will be d square plus 1 of y is equal to 2 sine 3x plus sine x. Here we are applying 2 sc, that will be s plus s. So you have d square plus 1 is equal to 0, so d is equal to plus or minus I. So cf is c1 cos x plus c2 sin x, and that will give you pi is equal to 1 upon d square plus 1 of 2 sin 3x plus sin x. So separating the terms, that will give 2 into 1 upon d square plus 1 sin 3x plus 2 into 1 upon d square plus 1 sin x. In the first one, You have to replace d square by minus a square. A is 3, so d square will be replaced by minus 9 because 3 square is 9 and minus a square is minus 9. But in second one, you have a is equal to 1. So d square will be replaced with a minus 1, and if you are replacing it with minus 1, then the denominator will be 0. So in the case of failure, you have to put x upon derivative of this term, that will be x upon 2d. So simplifying this one, that will give minus 2 by minus 8 sine 3x, and plus here you have x into 1 by d of sine x. 1 by d is nothing but it is the integration, because d is a derivative, so 1 upon d will be integration, and that will give you minus of cos x, because sine has integration minus cos. So your pi will be minus 1 by 4 sine 3x minus x cos 3x, and therefore the general solution is y is equal to c1 cos x plus c2 sin x minus 1 by 4 sin 3x minus x cos x. Okay, so this is the case of sine and cos.